This video. In this video, we are going to solve ride sharing application LLD. This was asked in MakeMyTrip and Swiggy. Without wasting any time, let's move to the problem statement. So in this problem, the application allows users to share rides on a route. Okay. Users can either offer a shared ride as a driver or consume a shared ride as a passenger. It can be multiple passengers as well. Users can search and select one from multiple available rides on a route with the same source and destinations. So this is a high level problem statement that was given in the problem and a particular use case that we need to implement as part of the solving this problem. Okay, so let's look at the use case. Application should allow to register users. So in our application, we should have a method create users which will take these input parameters name, gender and age for creating a user, and our system should have a user list with which we can create the users. So this will return the user object. Okay, user should be able to add vehicle. A user can have multiple vehicles. Okay, so whatever users we are creating in our application, that can register vehicle by providing their name. Okay, so this is going to be the name parameter, vehicle and their registration number. So this is going to be the second method that we need to implement as part of this solution. Users should be able to offer rides. Okay, this is the main thing that we need to implement as part of this solution. So this is the method offer ride, where a particular users can offer their own vehicle as a ride to other passengers when they are moving from one location to another location and have empty seats in their vehicle. Okay, so what are the parameters that we need to provide inside of our ride? Name, vehicle, seats available. This is an important thing, that how many seats are available, origin, destination, city and start time, when he is planning to offer this ride at the origin location. Okay, and the duration of the total journey. This is the estimated duration journey between Bangalore to Mysore. Okay, so these are the parameters that we need to implement, we need to provide as part of offer ride method. Users should be able to select rides based on origin, destination and selection preference. Users should be able to select ride based on origin, destination and selection preference. So there is another method that we need to implement is select ride, where we will provide parameters like the users or the passenger who is trying to select a ride for himself or along with his family or other family friends. So he or she needs to provide name, origin city from where he wants to select that ride, destination, seats required. This is important. Let's say if someone is offering a ride and seats required are not matching, let's say here the seat available is only 1 and here seats required is 2, then this ride offered by John will not be available to be selected for this particular user Smith. Correct? And earliest ending ride. What is this parameter? This parameter is the preference user want in this while selecting a ride. User can also have other preference than earliest ending ride, that can be lowest duration ride or preferred vehicle. They can also provide, let's say if they want 2 seats, right? So 2 seats can be available in a normal car or it can be available in a SUV. Correct? So that preference user can give, or a particular, or we can say, let's say they want to go via Mahindra XUV. If it is available in the offered ride, then they for a particular date and particular time between a particular destination, then this can be available. And most vacant, let's say they want 2 seats but one ride has 3 seats available and one ride has 4 seats available, correct? Then which ride user want to select for his ride is this one, fourth one, correct? User should be able to get all rides offered and taken by the user. So this is the main implementation that we need to implement as part of this problem statement. Now we need to identify first thing, what are the entities going to be involved in our solution. So as we can see these methods that we need to implement, one thing I can say that we need to create a facade class that will have all these methods: create user, offer ride, select ride, okay? And the entities that I can see, one is user and one is vehicle. That is very easy to identify in this problem statement. And the other one major entity that is going to be ride, that we will see. So let's move to the entities involved. First is user and vehicle. These are very easy to identify. Third one I already told you, ride. And then for ride we will have ride status, and for vehicle we will have a vehicle type, like it can be a scooty or a two-wheeler, two or four-wheeler, correct? That is the thing. Then for each entity we are going to have service classes for them and repository classes for them as well. So we can say user service for user class, vehicle service for vehicle class, and ride service for ride class, correct? Similarly we will have repository for each of the service. User will have user, vehicle will have vehicle repository, and ride service will have ride repository, and along with that it will use the user and vehicle repository. Then the most important thing that we need to implement as part of this solution are ride strategies. So we will have ride strategy interface that will have a method select ride, where we will provide all the offered rides as a list, okay? And these rides we can think of: earliest ending ride strategy, lowest duration ride strategy, most vacant ride strategy, preferred vehicle ride strategy. And if we can have one more like lowest price ride strategy, correct? Or we can have even more. We are not going to implement lowest price ride strategy as part of this solution, but we can see how we can implement that. We can discuss that part. So these things are at the overall level that we need to have. Then after that, for all these repository and service class, we need to have ride sharing facade class, which will have the methods that we require in the use case. Those are create user. Let me use this pen. This will have create user, add vehicle, let me just erase it, add user, add vehicle, offer ride, select ride, correct? These can be accommodated inside this facade class. Then we will have one more ride sharing demo class, where we will try to create object of ride sharing facade and try to input data like different users, different vehicles, and when try to implement different strategies to find the ride that our user is going to get. entity fields. Let's now move to the entity fields. That let me remove this. So as we can see here, the user entity is the simplest entity that we are going to have. Okay, that will have name, gender and age. That is simple. Then we will have vehicle entity. It will have vehicle name and vehicle owner name. Vehicle type is optional, uh, because we are providing vehicle name. Let's say we have Swift car or Activa, that we can provide. Otherwise we can also can mention as vehicle type as car or scooter, correct, and the registration number, that is important. Then we will have the ride entity. This is the most important entity of this question, as it will contains the details. When a particular user is providing offering a ride, then we need to create a ride which will have a unique ride ID. Okay, it will have origin and destination location. Vehicle for ride, one user can have vehicle 1, vehicle 2, vehicle 3, but he is creating ride 1 for vehicle 1, ride 2 for vehicle 2, correct. So that's why we need to have vehicle for ride. Total seats available for ride, ride status. Initially we will mark it as when it is when it is started. When user provide the create the ride, then we will can have start, in progress or complete status once it is completed. Then we will have ride user, who is this initially is going to be empty. When while offering ride, this field is going to be empty. While selecting ride, when this is selected, that passenger name would come here. Okay, then we will have ride fare. That is optional, as this is not part of the problem statement, ride fare, but we can use it if interviewer asks us to, like this is required actually. For any ride we should have a ride fare, correct, but in this problem statement it was not mentioned that we need to have ride fare, but this field needs to be added in the ride entity, because for every ride we should have a ride fare, correct. Then we will have start time, duration in hours, total duration, how much time it will take from to reach from one location to another. Then we will have end time. We will have ride status field, that is here, that can be start, in progress and complete. And in vehicle type we can have car and bike. Okay, so this we have discussed vehicle, ride and user entities, and we have discussed about ride strategies. We will see how we are going to implement these strategies, earlier ending ride strategy in our code, and we will see how we are going to implement our service, what methods our service and repository classes are going to have. Now let's move to the UML diagram. Okay, so this is the UML diagram that I have created. If you see, there is one ride sharing demo class that we are going to use to run this whole application, and this ride sharing facade class, if you see, it has all the methods what are present in the use case: create user, create vehicle, of a ride, select ride, and it will have all the fields as well inside it. And these two methods, get rides offered by user, get rides taken by user, right? These were also mentioned in the use case question description. If you see, user should be able to get all the rights offered and taken by the user. So these are also part of our system. So this facade class is taking help from user service class, vehicle service class, and ride service class. Okay, before going to service class, we need to check first entity classes that we have already discussed just now. Ride will have ride ID, origin, destination, vehicle for ride, total seats for ride, ride status, ride user, ride fare, start time, duration in hours, and the constructor and getters of those fields. And it will has a ride status which can be which can has many states, and ride also uses a vehicle. So vehicle will have vehicle owner name, vehicle type, and registration number. And user, ride will also have user. User will have name, gender, age, and vehicle has vehicle type, can be car and bike. Correct. Now let me just minimize this. Now let's see how our different service classes, let's say this is the simplest service, user service, create user, get user, and user exist or not, right? These methods we can use. In vehicle service we can use create vehicle or get vehicle. In ride service we will use both of these service, vehicle service and user service. If you see here, that we have not mentioned in the UML diagram, but in ride service we will be using them to offer ride, select ride, get rides offered by user, get rides taken by user. And this ride service will also use the ride strategy inside to provide the select ride, right? Here we need to provide the ride strategy, so we need to have ride strategy also inside ride service. These ride services are also going to use repository classes that are not mentioned in the UML diagram, because this diagram is getting bigger, that's why I need to remove those, but we will see in our code. So now let's move to the coding part. So here if you see, this is these are the domain entities. Here we have repository, service layer. We will cover these. Let me cover the user class first. So it will have three names, constructor and getters. Okay, then we will have vehicle, vehicle type, string, and then we have constructor and getters and setters. Inside the ride class we have multiple fields, as we already seen. We will have ride ID, origin, destination, vehicle for ride, total seats for ride, ride status, ride user, ride fare, start time, duration in hours. We have a constructor and getters and setters and toString method. So we are covered with the entities. Now let's see the service layer. Let's cover the user service first. So user service will have user repository in it, and we will initialize user repository inside the user service, inside the constructor. Then we will have create user method. Inside that we need to do all the validations, whether name is correct or not, or whether name exists or not inside this method call, as it cannot be empty or null. Again same for gender and for age, and age cannot be negative as well. If user already exists inside our system, then we cannot add that user again with the same name, gender, and age. So here we are creating the user if all the checks are passed, and then we are saving it in user repository. So here same, once it is saved, if we call get user, then we can get it from user repository from the name field, and user exist also we can check. So let me open the user repository we will have three basic methods here: save, find by name, and exist. Correct? If I try to see its implementation, save is simple. Users, we have a concurrent hash map, so that we want to remain a we want a thread safe solution, so we are using a concurrent hash map. So what we are adding inside as a key here is the user name. Okay, although we can have user id as well, this can be improved, but for now this is how we have implemented. Find by name method, how we have implemented, we are checking checks if it is empty or not, and then we are passing the value from this map. And in exist also we are just checking contains key. So now we are covered with user service. Let's see the vehicle service. Vehicle service will have vehicle repository and user repository. Inside this we need to use it. While creating vehicle, we need to check if for that particular owner or particular user, if that user exists, if when we are registering a vehicle in a particular user, that user should exist inside the user repository. This check is for that. If the vehicle already exists for this owner, then we are again checking find by owner and vehicle name method, because if it is present then there is no point of adding it again, right? Then we need to throw an exception. And if all the checks are correct, then we can create a new vehicle and save it in the vehicle repository. And here we have get vehicle method, where we will again use the same method, find by owner name and vehicle name. Otherwise we will throw exception here. So let's see the vehicle repository. Here again we have same methods what we have in user repository, save, and this method is for find by owner name. Let's see its implementation, how we are checking it. So again we have a concurrent hash map for vehicles by owner. So here we are registering vehicles, a list of vehicles inside owner name, a username. Okay, so that's how we are doing it. Now let's see the, before moving now we need to have write strategy interface. So here we have one method select ride, where we need to provide all the rights offered by the users, and then if someone want to select a ride, they will get a ride value here. Okay, so now let me move to the ride service. Ride service will use ride repository, user repository, and vehicle repository, and it has one hash map, rides taken by passenger, as we need to implement one method inside our facade class. For that we need to take this map. Whenever rides is selected by a particular passenger, we need to add into this hash map. Okay, with the username. Ride service we are defining it. Then we have offer ride method. Before going here, I think we need to discuss the ride strategies. We'll see. So here we will have different kind of validation for each field. That is good to have. And then we need to see if driver exists or not. Okay, we need to see if the vehicle exists or not. Then we need to create and save ride. So for new ride we need to have a unique value, origin destination vehicle, and here we are setting a status. Here we are setting a start when it is started, or we can also mark it as like ready for pickup, but I have taken it as start, so that is fine. And then we are saving it in ride repository. Let me have ride repository open here. So we have save method, find by id, as we need to we need to, there is can be a requirement when we need to find a ride by its id, find all, find by driver name, and find by origin destination. This method is very important, as whenever we want to select a ride, the first check we will do is origin and based on the origin and destination. So here we will do find all method that we have created for all the rides, and inside that we will put a filter for the get origin and get destination. Here we have uses the and condition. So if both matches, then only we will get the value of this. Okay, so here we are getting the eligible rides. Inside that we are again checking the seats required column, if you see, and we are checking the status if it is available for or not. We can I think we can change it for as available instead of start. And there is one more check that I have added. Passenger cannot select their own ride, right? There can be a possibility that I have given I have offered a ride, and at the same time I am also looking for a selecting a ride. So this should be the case that inside the list we should not get the passenger name as the ride username. Then we are collecting it, and if it is empty then we will return null, as we will not able to select a ride. And the strategy that we are going to pass in this method, ride strategy, if you see, inside that we will use the select ride method. If the select ride is not null, then after selecting the ride, if the ride is there, selected ride is there, right, then we need to reduce the number of seats available. Why we need to reduce it? Let's say one ride has 4 seats, right? One I came as a user and I booked 2 seats. Then what is the remaining seats would be 2 for this ride, correct? So that can again be available for booking, correct? That is why this condition is important, that we need to, from total rides available seats, we need to remove the seats required, and then we need to add it in that map that we have created for passenger name, ride taken by passenger, and here we will return. So here there are 2 methods. Before, I think these are very simple, as we are using the find by driver name and the ride taken by passenger hash maps. So I think the only thing that is pending now is to see the strategy, how we are going to select the strategy. Here we are getting the eligible strategy, right? So let's see. This is the earliest ending ride strategy, that is implementing the ride strategy. So here we will get all the rides where we need to filter it out minimum ending ride. So here we will get end time and compare it with the each of the end time. So whosoever is the taking the minimum time for same destination, that we can use it. Then this is the lowest duration. Again we will have a list of rides. Now you would argue that how we are here, we are only comparing the duration of hours, correct? But how from all the list, how we are going to ensure that it will have for same origin and destination? So when we are selecting ride, the first filtering that we are doing, in that method at the initial level before selecting the ride strategy. If you see in ride service, here we are using the ride strategy, correct, for eligible rides. But if you see in the eligible rides, we are checking these values: origin and destination, seats required, if it is available or start, or if it has passenger name, if it should not be equal to the passenger name, correct? Then we have most vacant right strategy. Here we are comparing the seats. Okay. And preferred vehicle strategy. So in preferred vehicle strategy, we need user need to pass preferred vehicle name. Let's say he would pass car name as Swift or Mahindra XUV. Then we need to for all the rides, eligible rides, we need to check if the vehicle name for required offered rides matches. Then we will just fetch that one, find first. Here we are using, otherwise we will return empty. Yeah, that's how the whole solution. Now let's see the demo. So inside the demo class, what we have done is we have created a set of users, then we created a set of vehicles for these users, then few of the users are offering a ride, 3 4, and then some of them are trying to select a ride. If you see Bob ride here, we are providing name, and for each, while selecting the ride, we are providing the different strategy: most vacant strategy, preferred vehicle strategy, earliest ending ride strategy. Correct. And then we are printing it out all the values. So let me try to run this program and let's see the output. So here we have created 4 users. So we have this message: users created successfully. We can have then we have added vehicle added successfully. Then we have offered these rides from Bangalore to Mysore in Swift at this time and for duration. Again, this is for same, and here duration is only 1 hour using the vehicle Activa. And then we will have for same location we have XUV, duration is 2 hours, and we have for same location duration 3 hours. Correct. Then Smith is trying to select the ride using the earliest ending ride strategy. Which ride is ending first? So here what Smith is able to, which ride is assigned to Smith? It is assigned to XUV. Okay. And Alice selected most vacant ride. Here also XUV is selected as it is the most biggest available. See here, initially there are total seats for available are 4. Then after Smith selected, Alice remains with the total seat side rides for 3. Once this is all Alice also selected, then it will remain 2 and someone else can also book it. Bob selected Activa. Okay, and total seats for ride is 0 now because it has initially Activa has 1 vacant seat. So ride offered by John. These are the values we are printing, and rides taken by Smith. This is what we are printing in the end. Rides chosen by Smith, rides by John. Okay. Here we have this get rights offered by user, gets right taken by user, and in the concurrent hash map we are storing that data. That is what we are getting here. I hope you like this solution. Please like, share and subscribe to my channel. Thanks for watching.